Hi, Senior One. Today we will talk about collective properties of solution and suspension and colloid. First, let's study the collective properties of solution. We have three main properties. We will talk about it: the vapor pressure, the boiling point, and the freezing point. We will study what happened to vapor pressure. It will increase or decrease, and also the boiling point. It will increase or decrease, and freezing point. We'll study what happened to vapor pressure. Let's study what meant by vapor pressure. Vapor pressure is the pressure exerted by vapor when it becomes in a state of equilibrium with the liquid inside the closed container at constant temperature and pressure. So when rate of condensation and evaporation of liquid inside the closed container become equal, the state of equilibrium happens between the vapor and the liquid and its pressure. So we will differentiate between the vapor pressure between the pure solvent and solution. The vapor pressure in case of pure solvent is high, but by adding a solute to solvent for making a solution, the vapor pressure will decrease. So we have a depression in vapor pressure by adding the solute. So if we convert the pure solvent into solution, the vapor pressure will be decreased. So the vapor pressure will be decreased. The second one is boiling point. The boiling point is temperature at which the vapor pressure of solution become equal to atomic pressure. Also we have value which is measured the boiling point, and measured boiling point is the temperature at which the vapor pressure of liquid equal pressure exerted or acted on it. And as the number of ions of solute increases, the boiling point increases. Because by adding a solute to the solvent, it causes elevation in boiling point. Because the bond which is between the solute and water is stronger than the bond between water, our bond among water molecules. So we need more energy to break this bond. So as number of molecules or as number of ions increases, the boiling point increases. So if we have NaCl when it is ionized into Na positive and Cl negative, and also we have another type of solute which is KNO3, which is ionized into K positive and NO3 negative. Each of them produce same number of moles of ions. So the sorry يا جماعة. So the boiling point of an aqueous solution of sodium chloride equal the boiling point of an aqueous solution of potassium nitrate. But if we have Na2CO3 and NaCl, which one has greater effect or cause increasing the boiling point? For sure Na2CO3, because Na2CO3 produce 2 Na positive and CO3 negative, while NaCl produce Na and Cl. So Na2CO3 produces 3 moles, but 1 mole of NaCl produces 2 moles. So as number of moles of ions increases, the elevation in boiling point increases. Number 3, freezing point. The freezing point of solution is less than freezing point of pure solvent, which forms it. The freezing point depression is directly proportional to the number of dissolved solid particles in the solution. The dissolved particle it may solid ions or molecules. When one molecule dissolved in water, is the causes decreasing in freezing point by negative 1.86. So when substance is not ionized in water, like sugar for example, C6H12O6, when 1 mole of any non-electrolyte is dissolved in water, in kilogram of water, the resulting solution freezes at negative 1.86. Example, solution 1 mole solution of 1 mole 180 gram of glucose, and 180 gram is the molar mass of glucose, in 1 kilogram of water freezes at negative 1.86 Celsius degree, and solid ions when the substance is dissociated into ions in water, for example NaCl electrolyte. The freezing point of electrolytic solution equal number of moles of ions times negative 1.86 Celsius. For example, the solution of 1 mole, the solution of 1 mole 58.5 gram of NaCl and 58.5 gram NaCl is the molar mass of it. In 1 kilogram of water we have 2 ions here, right? So it will decrease the freezing point by 2 times negative 1.86, which is equal negative 3.72. So if I asked you about to solve this example, what is the freezing point of the solutions that contain 1 mole of calcium chloride CaCl2 in 1000 gram of water? CaCl2 will dissociate into ions Ca and 2Cl, so it produces 3 ions. The number of mole times negative 1.86, which is negative 5.58. Now we'll talk about the mixture properties. The mixture may be solution and suspension and colloid. The mixture, it may be solution or suspension or colloid. First, let's study the solution. Solution is considered a homogeneous mixture which is diameter of particle is smaller than 1 nanometer. As the properties of solution, homogeneous mixture, and also diameter of its particle is very small, which is less than 1 nanometer, and the particle of solution can't be distinguished by the naked eye or by the electron microscope. The particle forming the solution are regularly distributed because it is so homogeneous in its composition and properties. The particle don't scatter the beam of light passing through the solution, doesn't scatter the beam of light passing through the solution. Number 2, the suspension. Suspension is a heterogeneous mixture in which the diameter of its particle is larger than 1000 nanometer and can be distinguished by the naked eye. The properties of suspension. Suspension is a heterogeneous mixture. The diameter of its particle larger than 1000 nanometer. The suspended particle precipitate if left for a short time without shaking. The suspended particles can be seen by naked eye, and the suspended particle can be separated by filtration, where the filter paper ultrafiltration membrane can hold the suspended particle while water passes through it. For example, sand in water and chalk powder in water. Number 3, colloid. And colloid is a heterogeneous mixture in which the diameter of its dispersed particles range between 1 to 1000 nanometer and can be distinguished by electron microscope. The properties of colloid. First, heterogeneous mixture, apparently homogeneous, and the diameter of dispersed particle from 1 nanometer to 1000 nanometer ranges between these two values. The dispersed particle don't precipitate if they are left without shaking. Example of it, like milk, for example, or blood. The dispersed particle can be seen under the microscope. The dispersed particle can't be separated by filtration. We can't filter our blood, for example, by filter paper. The shape depends on its concentration, and shape of it depends on its concentration. The concentrated colloid appear as milk, or cloud. Diluted colloid appear clear. We have a phenomena which is Tyndall phenomena. Tyndall phenomena to distinguish between colloid and the true solution. This is known Tyndall phenomena. By allowing a beam of light, we use a torch and allowing a beam of light from lamp to fall on each one. The colloid scatters the light because the size of colloid particle is large enough to scatter the light. So the colloid is intermediate case between the solution and suspension, because diameter of it ranges between 1 nanometer to 1000 nanometer. We have forms of colloid. Classification of colloidal system according to state. The colloid consists of dispersed phase and the dispersion medium. The dispersion medium here, it may be liquid or solid or gas. First, if the dispersed phase is gas and the dispersion medium is liquid, so it will be gas in liquid and it like the whipped cream or whipped egg, and gas in solid like sweet, like cotton candy, and also the liquid in gas like aerosols and fog, and liquid in liquid like mayonnaise, an emulsion of oil and vinegar, and liquid in solid like hair gel, and solid in gas like dust in air particle, and solid in liquid like pigment, blood, milk, and starch on hot water. When an amount of egg white is whipped by electric hand mixture, a colloidal system is formed. Now, and there is no gas colloidal system because the mixed gases are homogeneous mixture, where the colloidal system, as you know, is a heterogeneous mixture. We can separate the mixture by many ways. Among the methods to separate the mixture: filtration. We can separate by filtration. Separation the component of mixture of solid substance. Some of them are soluble and some of them are insoluble using filtration funnel and filter paper. For example, separation of sand from table salt in their mixture using water as a solvent. Number 2, evaporation. Separation the solid substance dissolved in solution by heating. Number 3, simple distillation. The separation solvent from the solution by heating and condensation. For example, separation pure water from salty sandy solution by evaporation. The condensation of produced vapor.